Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. So today we continue our lesson on Introductions to Scientific Programming, Chapter 7, which is related to graphic. Okay, so in this chapter it is not about the images or anything else. So it is all about how you wanted to create a representation of graph, plot lines, and so on. Alright? So let's take a look at the objective of today's lesson. Okay, so the first objective of today's lesson is to create a two-dimensional line plot function and the properties. Okay, so after you are learning this chapter, after you learn this chapter, you will be able to create and draw a two-dimensional line plot by using your own function, and also what are the properties that are available inside two-dimensional line plot. Okay, next objective is you also be able to create a subplot functions. So it means that you have set graph inside one full graph. Okay. So next is you are able to create a specialized 2D plot functions. So what is the example of the specialized 2D plot functions? So you must stay tuned in this chapter. Okay, so some of the example of specialized 2D plot function, for example, we have a discrete graph, which is the graph that changes over time. Okay, we have log, we have histogram, and we also have polar, bar graph, and also pie chart. But for polar, bar graph, and pie chart, we are not being covered in this chapter. Okay. Alright, lastly is figure editing using wizard. So at the end of this chapter, you also be able to learn how you wanted to edit the figure by using a GUI or a graphical user interface that has been designed inside MATLAB. Okay. Alright, so let's continue. So first part of the lesson today is all about introductions. Okay, so why we need plot? Okay, so plotting is actually a pictorial way of representing relationship between various quantities. So it shows how one quantity changes if another quantity that is related to it also changes. So actually we plot something, or we plot the data because we want to observe the relationship between one variable to another variable, okay, or maybe two variable to another variable. So it depends on your experiment. Okay, so it is actually the way that we wanted to represent, we wanted to tell the people what is actually the relationship in our data. Okay, so graph is also summarize huge information into one picture, thus easier to analyze the collected data. So for example, if you are collecting some data and you want it to represent what actually the data that you collect, so you can use a graph. So actually graph, it summarize all of the data that you have. Okay, so that you will be able to summarize, and you will be able to analyze, oh okay, this is the data that have been collected, and what are the analyze that you can get. So what are the conclusion that you can get from your data. Okay, the third reason on why you need to plot is it is an easy way of comparing multiple measured data. So if you have a measured data from one source and you have another measured data of another source, so you need to plot it because it is easier for you to compare, because you see the data. Okay, you just, you are not just take a look at the number, but you take a look at the pattern of the data. Alright, scientific data. So what is actually scientific data? So in scientific data, each recorded value is called a sample. So the collection of the sample form a data as a vector. Okay, for example, I want to collect the value of the water inside the, I wanted to collect the pH value of the river. Okay, but in one minute only. So in 1 minute, I want to collect 5 data. Okay, so it means that the sample that I have inside my data is a total of 5 samples. Okay, so the collection of the sample, it will form a data as a vector. So when I finish collecting my data, so it will be combined together to become a vector. Alright, so practically each of these samples is recorded according to the change of another parameter such as time, angle, distance, and etc. So in mathematics, this parameter is called function variable. Okay, we go back to the example of taking a pH value of a river. Okay, so we take the pH value, so we have the pH data. Okay, and then I get the data in every for example every 20 seconds. Okay, so those kind of the 20-second represent the other parameter, which is time. Okay, so in the experiment I already get two data. I get pH data and I also get the time. All right. Okay, so those kind of experiment, it will produce a function with respect to the time, because I collect the data by using an interval of time. All right. Okay, so for another example, Vt is a voltage reading over time or voltage function relating to time. So if you are recording a voltage value with respect to the time, okay, it will become V in the bracket T. So it will become V with the function of T. Okay, so thus recording scientific data will at least save two types of vectors. Okay, when you are conducting your experiment, you will be at least save two type of vectors. Either it is the data that you wanted to record it, and also maybe you also recorded the time where or when you recorded the data. Okay, so for example, the measured variable itself, the function variable. Okay, so this is the example of the scientific data. So for example, temperature recorded every 0.5 seconds for 1 minute. So the measured variable, so the variable that you wanted to measure is temperature. Okay, and then the function variable, you have time, which is start from 0 until 60 seconds, which represent 1 minute. Okay, the interval is here. Okay, 0.5 second. Okay, so when you are measuring all of those samples, you will be able to get a total of 121 sample. Okay, so this is the example of other scientific data example that you can take it as an example to improve your understanding. Okay, and then you can observe what are the measured variables, how the function variable is executed, and what is the number of the sample. All right. Okay, so next we will proceed to our main objective in this chapter today, which is how to plot those kind of data. Okay, so plotting the scientific data will be as follows. First, we need one axis, which is y-axis, measured variable. Usually we put our measured variable in y-axis, and x-axis is function variable. Okay, for example, if you wanted to measure the voltage, it will become in y-axis, and then you measure the voltage every 2 seconds. So your function variable is time. So time is actually x-axis. So usually we put measured variable in y-axis and function variable in x-axis. All right. So both main variable and function variable vectors must have the same length. Okay, so when you wanted to plot the data, you must make sure that the length or the size of the variable and also the function variable must have the same. It must be the same. So if it is not the same, it will MATLAB will give an error, and you will not be able to plot the data. All right. Okay, now let's take a look on how you wanted to create a 2D plot. Okay, so 2D line plot function. So if you wanted to plot some 2D graph inside MATLAB, a function plot can be used to perform a 2D line plot. So you can use a plot function. Okay, so the syntax for plot function is as follows. Plot, bracket, x, which is your measured variables, y, which is your function variables, and also line spec. So later on I will show you what are the properties or what are the options which are available in line spec. Okay, so this is the description of the syntax. So plot data in y versus the corresponding value in x, which can be either scalar, vector, or matrix. So you already learned about scalar, vector, and matrix, right, in previous chapter. So right now you already know what are scalar, vector, or matrix. Okay, so the size of variable y and x must be agreed. So as I said to you before, the size of y and x must be the same, so that it will be able to plot the data later on. All right. Okay. X data is actually optional, but if it is not specified, Y data sample number will be used. Okay, so actually the main variable or the main part that is needed in plotting the data is actually Y, which is the measured data. Okay, so X data is actually optional. All right. So line spec is also optional. So this define the line style, marker symbol, and color of the plotted line. So line spec is actually more related to the style, you know, dotted line, a solid line, or any other line. Marker symbol, if you want your line or your graph to have a marker, you can initialize it, and the color of the plotted line. Okay, you can also customize the color. All right. So let's take a look of the first example. Okay, so the first example asks you to plot a function y equals to exponential of x over 2 for x 1, 2 until 10. Okay, so this is how you are creating the exponential inside MATLAB. Okay, so first you will be creating a range of x first from 1 to 10 with the difference of 1. Okay, so if the difference is 1, you don't have to put a difference. All right, so this is the function of y, which is your measured, okay, exponential x over 2. Okay, and then you plot x and y. Okay, so for this function, okay, you see here, it will create an exponential graph with a total of 10, okay, x variable, and also a total of it has a maximum value of 10 and maximum value of 150. Okay, so because it is initialized in the exponential function. All right, so for this example, we are plotting by using two variables, plot x and y, and then it will give this variable. Okay, but can you try to plot you plot only y axis? So what will happen, and what are the differences between those two variables? So for this exercise, I want you to try by yourself and you observe. Okay, why? The answer is as you can get. Okay, why does the answer is like that? All right. So basically, what I wanted to tell you is that if we are plotting a variable, for example, you have recorded a total of 5 temperature. Okay, 5 temperature. And then you in 5 different time interval. Okay, and then when you plot data x and y, so x will be referring to the time and y will be referring to the temperature. Okay, but if you plot in the bracket of y, what will happen is that x-axis will become the number of the sample. Okay, so it will not become the time interval, so it will become the number of the sample. All right, for example, if your measured variable has 5 samples, so your x-axis will become 5. Okay, so it will not reflected to the time anymore. Okay, all right, because you only plot the measured variable. Okay, next is line spec. So what are the options that are available for you to customize your plot? Okay, so this is some of the variables or some of the customization that you can get. Okay, so the first one is the line style. Either you want a solid line, you want a dash line, dotted line, dash dot line, so you can customize your plot. Okay, and in terms of color, you can just put R for red, M for magenta, W for white, and so on. And also for the marker, you have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, you have a total of 13 different marker that you can use in your graph. Okay, all right, so look at example number 2. Okay, example number 2 asks you to plot a function y equals to sine 5x for x equals to 1 until 500 with the difference of 10. Okay, so first we initialize the variable x first. Okay, the variable x is actually from 1 to 500 with the difference of 10, and then y, which is the measured variable, is represented by sine 5 multiplied by x. Okay, and then plot the value of x and y, and then this is the line spec. Okay, The first one is the line style. So this one is actually a solid line. M is the magenta, okay, magenta color. And this one is like the marker. Okay, you see here, this is the marker. The marker that you initialize right now is like a round style marker. Okay, so this is how you can customize your line plot. Okay, so dash M O are line spec properties for solid line, magenta color, and circle marker. Okay, space between properties is optional. All right. So if you wanted to create another type of line spec, you can just refer to the MATLAB documentations. So you can just customize as you want. So what color that you want, what type of line, what type of the marker. If you don't have a marker, you don't have to put it. Okay, so it depends on you. All right. Okay, so this time plot Y will not work. Can you guess why? Okay, so I will answer to you because I'm sure that you will not try it, or maybe you are confused about that, right? Okay, so previously I already told you, if you are plotting only a measured variables, the x-axis will automatically converted into the number of sample. Okay, it is actually reflected to the size of y. All right, so you see here, the x is actually from 1 to 500, but with the difference of 10. Okay, and if you plot xy, you will have a range of from 0 to 500 because it is reflected to x, and you plot the value of x and y. But when you plot the value of y only, it will become the sample size. Okay, so for this example, the size of value of y is only 50. Okay, so when you try later on, you will see the end value of this graph will become 50. So it means that your graph is already not correct. Okay, so you must make sure that what are the specifications of the questions, and you must know how you wanted to create the graph based on the number of sample or based on the number of the function variable, which is x. So which type of variable that you wanted to choose, either it is the number of sample. So if x is the number of the sample, you don't have to put x here. But if x is the number of the, if x is actually the function variable, you must put x here. All right. Okay. Next is plot formatting. Okay. So in a plot, you must have some references. For example, the label of y-axis, the label of x-axis, the title, okay, and also the first part is the title and label. Okay, title, the function that you can use is, if you wanted to initialize a title, you must put title. For label x label, y label. The legend is actually, if you have multiple plot in one graph, you need to put a legend. Okay, for example, the red line shows a cat, the blue line shows a dog. Okay, so you must put a legend, and also you can put additional text inside your graph. Okay. Okay, next is the axis limit and aspect ratio. So in order for you to put your own axis limit, because if sometimes you wanted to limit your x-axis and y-axis, right? So you can just use the function of xlim and ylim. Okay, and the aspect ratio, you can use axis function. Okay, grid line and the grid, you can use grid for you to initialize a grid inside your graph, and also ticks. So you can learn all of this inside the and then you can try by yourself. Okay, you can customize your graph by using this kind of functions. All right, so I think next part is we are learning about multiple plots. So how we wanted to create a multiple graph inside one figure. Okay, all right. So next is all about 2D plot with several plot properties. Okay, so in this example, we are creating or displaying a sine omega graph. Okay, with a title of sine omega graph, an x-axis label of omega, and y-axis label of sine omega. Okay, so as usual, you put omega, which is the x-axis, and you put y, which is the y-axis. Okay, sine omega is actually the y-axis, and you plot both data because the x-axis is not represented by the number of sample. It is reflected to the omega. Okay, so you must plot both variable. Okay, and then you see here it puts the name of the x label. So x label is the name of x-axis, which is omega. Y label is the name of y-axis, sine omega. Okay, and then x tick format. All right, so this is actually the x tick format that you need to do. Okay, so the title is sine omega graph. So sine omega graph. Okay, so x tick format is actually we wanted to initialize a pi here. Okay, so if you wanted to initialize the pi here, you need to put this. All right, x3c0. I think this one is representing pi. And then if you wanted to show the grid, okay, so this is actually the grid. Okay, you see this, the blurring square here. So it is actually a grid. So you just put grid on and you can get this kind of graph. So this is how you can customize your graph with several plot properties. Okay, if you want your graph to have a grid, you must put grid on. If you wanted to put some labels in x-axis, you put x label, what is the label that you wanted to put, and so on. All right. Okay, so next is all about creating a multiple plot in a single graph. Okay, so multiple plot drawn on the same graph is very useful when we wanted to compare the data with different settings. Okay, so this kind of graph is actually really important if you wanted to compare the data. All right, so the syntax that you need to do is plot x1 y1. Okay, line spec. Okay, line spec for the first plot. Okay, so line spec you already learned in the previous slides. Okay, and then x2 y2, which is the part that you wanted to compare. Okay, the second graph, line spec of the second graph, and etc until xn, which is the final number of graph that you wanted to draw inside the final plot that you wanted to draw inside a single graph, xn, yn, and also the line spec for the n graph. Okay, so basically what you need to do is you need to put x variable, y variable, the line spec of the first graph, and you repeat it on the second graph, and you repeat it on the third graph, and so on. So it depending on how many plot that you wanted to put inside the graph. All right, as long as you have all of these specification, you fulfill this specification, or you fulfill this syntax. Okay, so for multiple plot, legend is used as the identifier for each plot. So it can be set by using the following function. Okay, so because you have multiple plot in one graph, okay, so MATLAB will be automatically put it into different color. All right, so actually if you wanted to represent to other readers, so people doesn't know what represent red, what represent blue, what represent yellow line. So what we must do is we must put a legend. So a legend is like a name of the line. Okay, so plot 1 legend, what is the name of the plot number 1, what is the name of the plot number 2, and what is the name of plot number n. Okay, all right, so we take a look at example number 4. So visualize the intersection of the two polynomials below. So for this example, we are drawing two different lines, the function of fx and the function of gx. Okay, and we wanted to observe the intersection of the two polynomials. All right, so plot the graph for x from 10 and negative 9.5, negative 8 until it reached positive 10. Okay, so to create this one, we just put this code, and then you see here. Okay, so the first part is plot x, which is the value of x here, f, the first function or the first line that you wanted to create. Okay, and then this is the line spec. Okay, this is a solid line with the x here. Okay, x is like a marker and m is the magenta, and then the second graph, okay, with the data x here, and the second function of g here. Okay, with the line style of dotted line, and then O is actually the marker O, and K. I'm not sure K, what is the color of the K. Okay, and you can go back to the previous slide and you can see what is the color of the letter K. Okay, and then we initialize a legend here because we wanted to differentiate what represent the first graph and what represents the second graph. Okay, the first graph represents the function of fx, and the second graph represents the function of gx. Okay, so we label the x axis as the x, and we put a title of intersection of two polynomials. Okay, so recap, line spec is optional, but if it is not defined for any line plot, the default will be used instead. Okay, so it depends on you. Either you want to use the line spec, but usually people are using it because it is easier for them to differentiate. Okay, because they know which one is which, because they are programming that kind of plot. Okay, so this is the example, or this is the output that you can get. Okay, the first graph, you can see that it is the color of the magenta, okay, with the marker of x with the solid line, and the second line is the dotted line with the marker of circle and with the color of black. Okay, and then this is the legend. Okay, the legend will give the representation name for each line. Okay, so the magenta line is actually the function of x. The dotted black line is actually the function of gx. So this is actually a legend. Okay, and then you put the name of x-axis as x, and you put the title of the graph, which is intersection of two polynomials. So this is how you can create a multiple plot on a single graph. Okay, so if you are asked to create a multiple plot on a single graph, you must put a legend. Okay, so that people will know which one is which. All right. So next is subplot function. So subplot is actually two different or multiple graph inside one figure. Okay, the previous example shows multiple plot, so it means that you have multiple line in one graph, okay, in one figure. But this one, you have multiple graph in one figure, so you can see the difference later on. All right, so subplot function. So an array of plots can be created in the same figure. Each of these plot is plotted as a subplot. Okay, so the syntax of subplot is subplot M, N, and P. So what are M, N, and P? So M and N, it will specify the grid division or size slot on the current figure. Okay, so actually M is actually the row and N is actually the column. Okay, so if M equals to 2, N equals to 1, it means that you have 2 rows and 1 column. Okay, so it is simply like that. Alright, P, define the position of the particular plot in the divided figures grid. Column first and then row. Okay, P is actually a position of the plot. For example, it will finish the numbering of the column first, and then it will proceed to the row. Okay, so later on I will show you how the plot is positioned based on the value of P. Alright, so subplot, upper and lower plot. Okay, so upper and lower subplot can be defined by 2 by 1 grid. So 2 rows, 1 column. Okay, so example number 5, create a figure with 2 stacked subplots of y equals to cos 3x and z equals to sin x for x equals to 1, 2 until 10. Okay, so you can just copy this code. Okay, what we wanted to focus here is that we wanted to create a subplot. Alright, so we put subplot here. The plot has a total of 2 rows, 1 column, and then this plot will be positioned on the first position, which is on the above. Okay, and then plot xy. Alright, so it will plot x versus y. Okay, and then the title will become y equals to cos 3x. Okay, because the function y here equals to cos 3x. Okay, and then the second figure that you wanted to plot is that you need to put subplot, the similar size. Okay, the number of row is 2, the column number is 1, and then the position is number 2. So it means that this kind of graph will be put below the first graph. Okay, because the position is right now number 2. Okay, so the title is z equals to sin x. Okay, you see here. So this is the plot which is the position number 1, and this is the plot which is position number 2. Okay, so you can see here that it will create 2 different graphs in one figure, and then it will name as y equals to cos 3x and z equals to sin x. So you can also customize your title of your each graph and your x-axis, your y-axis, and your line spec. So you can just modify and you can just customize your graph. Okay, so this is how you can create a subplot of two different rows. All right, so next is the example of subplot for RC circuit. Okay, so let's take a look at example number 6. So in analyzing an RC circuit with an AC input voltage, two responses need to be plotted. So they are magnitude and phase responses. So below is the equations to obtain both responses, where R is resistor value in ohm, C is the capacitor value in farad, and F is the frequency of the AC input voltage. So you see here, we have a total of three different types of equations. Okay, so in MATLAB we can use function absolute H and angle H to automatically compute magnitude and phase from H respectively. So for this function, you can just refer to the MATLAB documentation on how you wanted to use abs and also angle. Okay, so magnitude is a ratio, thus it has no unit. On the other hand, the unit of phase is radian. Okay, so the question asks you to write a MATLAB script to plot both of the magnitude and phase responses when R equals to 4.7 kilo ohm and C equals to 0.47 microfarad for the value of F between 0 to 10 kilohertz. Okay, for this example, you can just substitute the value here and then you draw it into the function of F. Okay, all right, so the magnitude and phase is actually the measured variable. Okay, the frequency here is actually the function variable. So it will put in x-axis and this one will put in y-axis. All right. Okay, so this is the coding for example number 6. So first you need to initialize the variable first, and then what we wanted to focus is here. Okay, subplot 2, 1, 1. Okay, it has 2 rows, 1 column with the position of number 1, and then you plot, okay, F over 1000 and the magnitude. All right, X label, frequency, you put a label of X, you put the tick format, okay, kilohertz, you put the Y label. So this one is actually you wanted to put the tick, actually the x-axis tick in terms of kilohertz. You wanted to put the unit, okay, similar to this one, and then you put the Y label, which is the magnitude. And but this time the plot number 2, okay, the below plot, you are putting like a symbol here. Okay, in front of circle, it's like a pi here. All right, so this is how you wanted to put a symbol or any other variables or any other what we call letters inside your tick. Okay, inside your y-axis tick, x-axis or y-axis tick. Okay, you can see here, this is how you wanted to create. Okay, this is the tick. Okay, so if you wanted to put the unit here, you need to do it like this. Okay, x tick format %.0f, and then you put the unit here. Okay, kilohertz, meter, centimeter, so it depends on your questions. Okay, all right, so okay, so for this one, I already said that the y-axis we are putting pi here, that's why we put this value. Okay, we put this format. Okay, y tick format is .1f/x3c0. so this is how you wanted to create a pi symbol inside your graph. Okay, this is the tick for y-axis. All right, okay, so next is a quadrant. Okay, so quadrant subplot can be defined by 2 by 2 grid. So previously we are creating a subplot of 2 different subplot, one at the above, on the second one on the bottom. Okay, but this time we wanted to create 4 different graphs altogether inside one figure, so we call it a quadrant. So quadrant subplot can be divided by 2 by 2 grid. Okay, for example number 7. So the example number 7 asks you to plot 4 sinusoidal signals of 4 different frequencies. So they wanted you to plot a signal of 4 different frequencies. F equals to 1 Hz, 2 Hz, 3 Hz, and 4 Hz on a single figure. Okay, so you must plot the signal for t equals to 0 until t equals to 1 with a difference of 0.001. Alright, So you can see here we are using for loop to plot this function because it is actually like a sequence, 1 Hz, 2 Hz, 3 Hz, and 4 Hz. So we can use for loop. Okay. So what we wanted to see here is that we wanted to see how we are plotting the data. Okay. So you see here, this is the measured value. Okay, the measured variables, and then this is the subplot variable. So subplot a total of 2 rows, a total of 2 columns. Okay, because we have 4, it must have 2 rows and 2 columns. Okay, it depends on your applications. F is actually the function of f here. Okay, we wanted to customize the position based on the loop. Okay, and then plot ty. Okay, y label equal, we are creating y x label here. Okay, y string, because we wanted to put y label here. Okay, y label is sign. I'm not sure 2/pi if I'm mistaken. So it depends on your inilah. Okay, y label in the bracket of y string. This is y string. Okay, title string. Okay, and then title with the bracket of title string. So you can just put your title inside the, because we are not putting the title directly, because we are putting it inside the loop. Okay, because we wanted to get the variable, we must use printf. Okay, we get the variable f here. Okay, that's why we are not putting this kind of float directly inside title. All right. Okay, so you see here, this is how you can create a quadrant subplot. Okay, plot with a total of 4 different graph. Okay, so the first cycle, so this is the position number 1, this is the position number 2, this is the position number 3, and this is the position number 4. Okay, so you must make sure that which position that you want your graph to put. Okay, that you wanted to put your graph onto. All right. Okay, so next we will be learning about a special plot. So what is actually special plot? So the first part of the special plot is related to discrete graph. Okay, what is actually discrete graph? Okay, so in order for you to create a discrete graph, later on you will be learning inside your discrete programming or discrete control. So when you are asked to draw a discrete graph, you need to use stem. Okay, stem function is used to plot discrete sequence data. So after this, you will be able to differentiate what is a discrete graph and what is a continuous graph. All right. Okay, so the syntax is stem x, y, and also line spec. Okay, so description of the syntax is plot the data in y at values specified by x. Okay, so x data is also optional in the discrete graph, but if it is not specified, y data sample number will be used. So it is similar with the previous plot function. Okay, so if we are not providing any x data, it will use the data number. All right. So line spec is also optional. So this defines the line style, marker symbol, and color of the plotted line. All right. So line spec is actually similar to the one that we have learned before. Okay, example number 8. So this example asks you to plot discrete signal of sine omega n for n equals to 1 until 100 with a difference of 1. Okay, by setting omega equals to 0.04 pi. Okay, if the question asks you to plot a discrete signal, you must use stem. Okay, it is actually replacing the plot into stem. Okay, if it is continuous, you use plot, but if it is discrete signal, you use stem. That's all. All right, and then as usual, you put x label, y label, and also you put the title. All right. Okay, so this is actually a discrete graph. So discrete graph is actually graph which is not continuous. Okay, of course, because it changes over time. And then it is actually different data at different time. Okay, later on you will learn in other subject what is discrete and what is continuous signals. Especially I think in digital electronics you will learn on this definition. What is discrete and what is continuous. Okay. So if you ask to plot a discrete graph, you need to use stem. Okay, but other than that you can use plot. All right. Okay, next is logarithmic plot. Okay, so a logarithmic scale is a nonlinear scale used when there is a large range of quantities. So logarithmic is actually a quantities where the basic value is really large. So people are using logarithmic. So logarithmic is actually 10 to the power of something. Okay, 10 to the power of 1, 10 to the power of 10. So all of those things are logarithmic. Okay, so common users include, okay, so people are usually used for earthquake strength, scalar Richter magnitude, sound loudness in decibel, pH for acidity, or frequency range. Okay, so for frequency range we will be use BODE plot. Okay, so syntax. So syntax for logarithmic plot, okay, you must use semi-log x, okay, xy line spec for x-axis loop plot, semi-log y xy line spec y-axis loop plot, and log xy line spec for both axis loop plot. Okay, so you can learn and you can try by yourself what are the differences between semi-logs x, semi-logs y, and also log. Okay, so one of the example of logarithmic is loudness. Okay, so let's take a look at example number 9. Okay, environment loudness strength of sound was recorded on several occasions as below. So plot the data using normal plot and logarithmic plot and then compare the two plots. So you can see here, right, the loudness value is really high. So for example, 3.16 times 10 to the power of 8. So this number is very large. Okay, so that's why we are using logarithmic plot. All right. So this is how we are creating a logarithmic plot. This is a variable L 7.94 with the exponential of 2 is actually 10 to the power of 2, 10 to the power of 6, 10 to the power of 8, 9, 10 to the power of 9, and 10 to the power of 11. So you initialize the variable here because each variable represent each area, okay, inside the table that you see here. All right. Okay. Alright, so this example, it will show you the differences between normal plot and also log plot. Okay, so this is the part where the normal plot that you are getting. So in this example, we are creating subplot, one plot on the above, one plot on the bottom. Okay, so the plot on the above is actually a normal plot because we are using plot. Okay, and then it is as usual, text, labels, okay, and the title. And then the second part is we are using semi-log y. Okay, and then you can see what are the differences. Okay, so this is the differences between normal plot and also log plot. Okay, so you can see here for normal plot, it will only initialize the variable of y-axis based on the highest power of 11. Okay, therefore you cannot see much differences between library, cafeteria, car, train, motorcycle. Okay, it's just a slight differences, but actually the differences is huge. Therefore we are using log plot. Okay, you can see in log plot you can see the major differences between the library, cafeteria, and so on. Okay, the data is similar, but the way the data is plotted is different. Okay, so if you have a large value of data, you must use log plot so that you will be able to see the differences. All right. Okay, next is BODE plot. Okay, back to example 6 of magnitude and phase are actually better plotted using BODE plot since they are important information in the lower frequency range. Below is how they are plotted with BODE plot. So when you go back to the example number 6, which is related to the RC circuit, okay, the circuit that we are learning previously. All right. So you can also create a magnitude and phase in terms of BODE plot. So if you are not learning about BODE plot yet, so it's okay as long as you know how to create or how to plot a BODE plot, because later on I'm sure that you will be able to learn BODE plot in circuit theory or in your circuit subject or in your control subject. All right. Okay, so as usual, so this is the way that you are using your BODE plot. Okay, so C, R, F, so H. Okay, so it is actually just use the equations. Okay, so magnitude is actually 20 log absolute H, and also phase. Okay, so what I want to say here is that if you are using a BODE plot, you must use semi-log x. Okay, see here, if you are using a logarithmic, you are using semi-log y. But if you wanted to create a BODE plot, you must use semi-log x. Okay, and then as usual, x label, y label, and also xstate format. Alright, so note that magnitude is also better represented in log. However, it is already done via formulation, thus no need plot for the magnitude. Alright, okay, so you see here, BODE plot is actually a plot where the x-axis represents the frequency, because the frequency is actually really high. Okay, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3. So those value is really high. So that's why we are using BODE plot. Okay, so for you to initialize BODE plot, it is actually semi-log x. So for you to use standard logarithmic, you can use semi-logs y. Alright. Okay, so this is the example of the BODE plot that you can use inside MATLAB. Alright. And the last part of the special plot is histogram. Okay. Alright. So histogram plot could be performed by using histogram function. So you can also design your histogram by using histogram function. Alright. So the histogram function automatically chooses an appropriate number of bins with a uniform width to cover the range of values in the data list and show the shape of the underlying distribution. So the syntax that you can use is histogram, x is the data, and the next part is the number of bins or the edges. Okay, so the description is x is the data to be plotted. So if you have a data that you wanted to translate it into a histogram, you can just put it. Okay, so nbin is a scalar defining the custom number of user-defined bins. Okay, if you wanted to have 5 different bins, you can put 5. Okay, and also the edges is a vector defining the bin edges of the histogram. Okay, so after this I will show you what is the effect of different number of edges. Alright, okay, so next is the test score. So below is a program code to visualize the test 1 score of a class when uniformly grouped into 4 and 20 score ranges. So for this example, you can just use your own data. Alright, okay, so this example are combining together. Alright, combine it together, the way that we are reading the data, we are loading the data from XLSY that we already learned in the previous chapter. Alright, and then you see here we use subplot. Okay, subplot, it will create 2 different, you see here it only have 1 row but it has 2 columns. Okay, it is position number 1 and it is at the position number 2. Alright, so the difference that it has only on the this one, marks 0 to 40 with the difference of 2, 0 to 40 with the difference of 10. Okay, so it means that the histogram will start from 0 and it will end at 40, but the bar width is 2. Okay, you see here, this histogram start from 0 until 40, but the width of the bar is 10. Okay, so this is the output. Right, you see here, so this is the histogram that has been created. Okay, so you see here, this histogram will be created based on start from 0 to 40 with the bar width of 2. Okay, that's why it has more segment here, but this time it will start from 0 to 40 with the bar width of 10. Alright, so this is the difference between, okay, this syntax, histogram, marks, which is the data that you wanted to put, 0 to 40 with the bar width of 2. Okay, alright, okay, so the last part of this chapter is plot editing using plot tools. So how you wanted to edit your plot by using tools. Okay, so alternatively, MATLAB plot figure could be customized using a GUI based interface called plot tool. So MATLAB already designed a GUI that you can use to edit your plot. Okay, so plot tools icon is available from the figure window. So when you are plotting inside MATLAB, this figure will be appeared. Okay, and then this you need to click at this icon. All right, if you click at this icon, it will display this one. All right, so this is where you can edit your plot. Okay, either you wanted to modify the name, the color map, the figure color. Okay, and to customize object in your graph, you can set their properties using the properties editor. So for example, click at the axis to display a subset of common axis properties in the property editor. Specify a title and an axis label by typing text in the empty field. Okay, you can see here. Alright, you can click at edit and you can click at the property editor. Alright, so this window will be appear for you, so you can customize the title, x-axis, y-axis, z-axis, and you can customize the font. Okay, in x-axis you can customize the x label, the limit, okay, the scale, the locations, the ticks. Okay, you can just do whatever you want with your graph. So it is easy for you to customize your plot inside MATLAB, okay, by using property editor. All right. Okay, so I think that's all for today's class. So I hope that you will be able to understand what is actually what is actually graphic in MATLAB and how you wanted to create different types of plot with different type of properties, and when you wanted to use plot X only. I'm sorry, when you wanted to use plot Y only, and when you wanted to use plot X, Y. Okay, and how you wanted to create a multiple plot, and how you wanted to create a quadrant plot, and how you wanted to create legend, and how you wanted to create a special plot. Okay, so as usual, if you have any question, you can just ask me in the WhatsApp and I will answer your questions. Okay, so guys, I think that's all for today's class. We will meet again next week, and that's all for today. Thank you.